We're on properties and classification of matter. So these are grade 8 and 9 concepts, but it's a lot to remember, and so reviewing it every year is good. Okay, so people didn't used to know what everything was made out of. Okay, and they used to think it was made out of earth, air, fire, and water, the elements. Aristotle, a bunch of guys, that's what they thought. Okay, now we know better because we've spent a lot of time doing our science, and we've also discovered that certain things have physical properties and chemical properties. Okay, so boiling point, melting point, malleability, ductility, color, state, solubility, crystal formation, conductivity, magnetism. Okay, so you want to read these definitions and basically memorize them. Okay, chemical properties, same thing. Okay, memorize this if you as best you can. If it can burn, that's a chemical property. Flash point, it's also has to do with burning. Okay, what temperature it's going to be before it lights on fire. What happens in air, like does it rust, does it tarnish, react with water, does it do anything? Okay, or nothing. Reacts with acids, heat, and then what goes on with acids and bases. Okay, so nobody really uses red and blue litmus anymore. They use these little metal things that you put in a pH tester. Okay, but we still learn it because that's what the book says. Okay, we also like to classify our pure substances and mixtures. Okay, this chart is in your book for grade 8 and grade 9 and grade 10, obviously. And I find kids can usually figure out the difference between pure substance and mixture. Okay, but where they get tripped up is these two, suspensions and colloids. And then sometimes they call this a homogeneous mixture or homogeneous, I don't know how to pronounce it, okay, or a heterogeneous or heterogeneous. The clue there is hetero, it means different, okay? Homo means same, okay? And that's what we're going to go through in a few minutes on PowerPoint and better pictures, okay? But I do want to point out that it exists in your textbook, okay? So chemical reactions. Some more words there, page 15. Recognizing chemical reactions. You want to read that. And we also are going to cover chemical and physical changes. Okay, so you might think that's the same thing as chemical and physical properties, but they're different. Okay, fermentation is for making wine and beer. Metallurgy has to do with making things out of metal, like a sword. Okay, salting. And like this Aristotle guy, right? This is the one who said things that are earth, fire, air, water. Okay, I'm more into pictures, right? Like all those words are great, but I like it better when there's pictures. Okay, and then the law of conservation of mass. So that's saying that you can't create or destroy matter, right? We're not God. Okay, alchemy was the thing. People were hoping that they could turn lead or whatever into gold. Okay, but we can't, right? They didn't know, but we do. Okay, then there's models of the atom. These are the most important guys: Dalton, Thomson, Rutherford, Bohr. Okay, there's much more elaborate models now. Okay, but these are the ones you tend to have to learn, and we'll spend a lot more time on those guys. Okay, and do a project with the models of the atom. So stay tuned for that. Okay, bye-bye models of the atom. Let's focus on chemical and physical properties for 11 minutes. Okay, so physical properties have to do with, first of all, whether something's a solid, a liquid, or a gas. Okay, and just because it's in grade 5 and grade 7 doesn't mean you remember. Okay, so a gas takes the shape of the container. It fills it up. All these little circles represent the particles. Okay, and they have an indefinite volume. That means the volume can change, and an indefinite shape, so it can change shape, no problem. Okay, liquids take the shape of their container. Oh, I wonder if I have that cat joke on here. There's a cat joke. Let's see if I can find it. Cat liquids container. It's like, yeah, these are hilarious. Okay, it's like proof that cats are liquids. Okay, because cats take the shape of their container. Yeah, right. I'll have to say that, put it on the website for you. Okay, so let's get back to paying attention. Solids stay their own shape. They have a definite volume and definite shape. Okay, what messes people up sometimes is Jello, right? Is kind of like solid, is kind of like kind of liquidy, it moves. And then same with sand. Each sand particle is a solid, but it can flow, right? So it doesn't really matter if you can pour it, but what is the actual particle? Is the particle of sand itself a solid? Yes. Okay, and that's properties. Okay, physical and chemical properties. So these are your chemical properties. So if something can react with an acid, that's a chemical property. Okay, some things don't. React with water, what it does in air, in reaction to heat. Right, so those are chemical properties. Here's your physical ones. Okay, so melting point, boiling point, hardness, malleability, ductility, crystal shape, solubility, density, and conductivity. Okay, I find reading definitions is really fun, but I like experiments better. Okay, so don't try this one at home. Okay, some of them you can. Do not try this one. It is very dangerous. How do I know? Because I tried it once. Okay, and the pickle exploded. Okay, so we're going to ask the crazy Russian hacker to show us how to do it. Okay, it's showing that.
Do not try this at home.
Yeah, see, he even said don't try this at home.
If you do it alone. Safety is number one priority.
Safety number one.
And we have always fire extinguisher close by, so we are in a safe environment. And today we're gonna make pickles glow. You guys excited? I am.
I am.
Let's check it out.
Yeah. Sorry, I keep hovering over. I'm looking for the mute button because I like muting these guys when they talk. So a pickle has a lot of salts, dissolved salt in it. So when you're doing electricity in grade 9, you learned that electrolytes are able to conduct electrons, able to conduct heat. And in this case, we're going to have electrical energy from the wall go through the electrodes, which are the metal sticks, through the pickle, and it's converted to heat and light. Okay, so what are we learning here? Conductivity. Okay, some substances conduct electricity or heat. In this case, it's both. Okay, so is a pickle an insulator? No, it conducts electricity. Okay, let's watch.
For this experiment, we're gonna need microwave safe plate, cucumber, and stick on the other one like that. Make sure these wires do not touch each other inside of a pickle and have a good amount of space between each other. As you can see, this wire not plugged up and this one is turned off. Then we're going to plug it in with the alligator wires. Then we're gonna plug it on here and turn this on. Let's see what happens.
There you go.
Now check it out. The cucumber glows. Isn't that pretty cool? Check it out.
Check it out.
Isn't that cool?
That's very cool. Okay, this one is a battery. Okay, not quite as exciting.
A bit to break up all the little juice packets inside.
Okay, so he's taking a zinc-coated nail and a piece of copper. Okay, and he's going to use them as electrodes and connect them to the lemon. So if you put them in a block of wood, nothing would happen. Okay, it doesn't conduct electricity because it's an insulator. And the metals, okay, let me grab you a piece of periodic table here quick. Periodic table. Okay, these ones conduct electricity. Okay, these are metals, so we'll spend more time on a different day about periodic table. Okay, but things on the left are metals. They're more likely to conduct electricity and heat. Okay, like look at that one, iron, right? That obviously does. Copper, for sure. We use that in all our wires on purpose because, well, it's affordable, but also because it conducts electricity really good. And we don't like it as much in tubing anymore for pipes for water. And we use plastic instead, okay? But it, because we don't want it to conduct heat that much, right? So we've switched to plastic. Okay, these guys on this side, the non-metals, they are insulators. Okay, they are terrible at conducting heat and electricity. Okay, so like air, right? These are all gases on the right-hand side of the staircase. Okay, they didn't draw a staircase on this one. I like how it pops up though. That's pretty cool. So those are insulators. So going back to our physical properties. Okay, that was conductivity. Okay, let's look at density. What's density? Okay, density is how close together the particles are. Okay, so making density towers is kind of fun. You pour a bunch of random liquids and solids together and see which ones float. Okay, so when you do that, you need to pour it down the side and make sure they don't mix. Okay, that's key. Okay, because then it messes up your density tower. Okay, this is a really fancy one because it has like 20 things in it. For yours, when you make it, you just need to have 5. Okay, so pick things that don't mix very easily, like vegetable oil. This is water with food coloring. Okay, just ping pong ball, piece of metal. This is dye like a dice, but you can't see it very good because it's in the milk. Okay, maple syrup, corn syrup. So the most dense things are going to sink to the bottom, and the less dense materials are going to float. Okay, so that's a property. Solubility is whether something can dissolve or not. Okay, so I'm going to write that down. Density tower and solubility. Okay, you're going to have to show me something that does dissolve in water and something that doesn't. Okay, so plan on going to the kitchen shortly. Okay, crystal shape can help us identify what it is. Okay, so this was a grade 7 planet Earth concept. And at the time you might have had to memorize them. Okay, probably not. And they can be very pretty, right? Like a lot of our gemstones are crystals. Okay, lots of people are into crystal healing and stuff like that, and protection. Okay, so the specific shapes are like orthorhombic and whatever. Okay, quartz, for example, always looks kind of like this, like the way it breaks. It's called cleavage, the way it breaks, and fractures if it's all jagged. So often you can tell it's quartz just by looking at it because it's clear like this, and its shape. Okay, so that's what crystal shape is about. What else we got? Ductility. This is one that kids never know what it is. Okay, it's can you stretch it into a wire? Yes or no? If you can, then it's ductile. Okay, so my example for ductile is this one. Okay, just since I have this open, okay, what's this one? Conductive. Okay, so if you can conduct electricity in, I don't know what that is, lemon juice, okay, and make a little LED light up, then it's conductivity. Okay, what else we got here? Malleability. So if something is malleable, that means you can change its shape, right? So gold, tin foil. My favorite example is Play-Doh. Okay, Play-Doh is malleable. That's why we have a picture of, I don't know what's his name, Charizard, Charmander. Okay, the Pokemon. So one of the kids made this Play-Doh Pokemon, okay, to show malleability. Okay, next one we have melting point and boiling point, and then hardness. Okay, my video is going to run out, so I'm going to have to save it and explain that separately.